Good afternoon, everybody. So, the second problem we covered today in class is an out of control car is speeding towards civilians at 40 meters per second. Spider Man jumps in to save them. He's able to stop the car at a rate of 14 meters per second squared. How many seconds does it take to stop the car? So, let's go ahead, let's list out our variables, write out our equations, and figure out how we're going to solve this one. So our equations are S equals xi plus vit plus 1 half at squared. And then acceleration is equal to vf minus vi over t. And our variables, as always, are s, xi, vi, vf, a, and t. So, from looking at this equation, from looking at this problem, I can see at 40 meters per second. It's out of control and it's speeding towards the civilians at 40 meters per second. So my initial velocity is going to be 40 meters per second because that's what we're starting at. Okay? So 40 meters per second. And then Spider-Man jumps in to save them. He stops the car. That's a key word. That means our velocity at that point is going to be 0. Well, that's our final point because he's stopping the car and then the motion is done. So that's our velocity final. So our velocity final is 0 meters per second. And then he stops the car at a rate of 14 meters per second squared. Now, a rate implies some change to something. So that means something is changing over time. In this case, we can tell it's an acceleration because we have the units of meters per second squared. So that's the change in velocity, meters per second, over to time, seconds. So my acceleration is 14 meters per second squared. So when you're looking for your variables in the problems, you're looking for these keywords, stop, rate, you're looking for units, and you're looking for motion. So we see meters per second, we know that's velocity. We see meters per second squared, we know that's acceleration. So I've got velocity initial, velocity final, and acceleration. I want to find time. And clearly, I want to use this equation to do it because I have all the variables except for t. But I'm not currently solving for t. So let's rearrange this one real quick. So I'm going to rewrite it over here. So let's make sure I don't fall out of the camera light. A equal to Vf minus Vi over T. To get T by itself, first I need to get it out from under these two, so I need to multiply both sides by T. Okay, that cancels these out, so then I have TA equals Vf minus Vi. And then to get T by itself, then I need to divide both sides by acceleration. And then acceleration cancels out on this side. So I get T is equal to Vf minus Vi over A. So they just traded places. Great. That works just fine. So then, if we plug in our numbers, we will have a Vf of 0 minus a Vi of 40 all over an acceleration of 14. So, what do we get when we plug those into our calculator? Now notice, 0 minus 40 is a negative number. So negative 40 over 14. Wait a minute. If I divide a negative 40 by a positive 14, I'm going to come out with a negative time, and I can't have a negative time. That wouldn't make sense. So I've missed something. When we're slowing down, our acceleration and our velocity need to be different signs. If we're speeding up, then they're the same sign. So that's a really good point. My acceleration should be negative. Now, it isn't negative in the problem, but that's something that I'm going to have to look out for. So when we're looking at problems, we should be looking, the car is stopping, so we know the car is slowing down. It's telling me the rate, but the rate is an absolute value. It wouldn't matter whether it's negative or positive. It's always going to be an absolute value of 14 meters per second squared. So when I bring that into my variable list, I have to think about it. It's going to be negative. And So I've got a negative 40 over a negative 14, and that's going to equal a time of 2.857 seconds. There we go. So keep that in mind as you go through these problems. You're the one who has to choose where the 0 is. You need to figure out where my negatives and positives are. Sometimes that will be given to you, but it's still something you need to think about. Okay? So then, as always, we want to put it back in our variable list, 2.857 seconds, and then we box it because that's our answer, and everything's perfect. Thanks, guys.